Okay, this video is about section 6.2, which is absolute value inequalities. And remember last time when we said when you solve an absolute value equation, right? Last time it was solving absolute value equations. Today it's solving absolute value inequalities. So when solving absolute value inequalities, you do just like you did last time in that you have to write two inequality equations. Okay, so it's very similar to what we did last time. Remember last time we said whatever the stuff is underneath the absolute value, you just automatically set it equal to the positive of this number and the negative of this number. Well, if you have an inequality, it depends on if the inequality is a less than, right? There's your less than, or if the inequality is a greater than. So there's your greater than. Okay, so in the first situation, if it's a less than, you're going to write your two equations. You're going to say either the stuff underneath is less than that number, but you're also going to say that the stuff underneath is greater than the negative. So we're still doing the positive 2 and the negative 2. The difference is that the first one you keep the same thing, the less than. The second one you flip the inequality and you say greater than. And then because you're going to have two solutions, you want to combine those inequalities to get one solution. And so because you have these two solutions, your answer is going to be the intersection of those two solutions. Intersection, meaning where do they overlap? Okay, so let me do an example. Look at the first one. Notice the absolute value of x plus 2, it says less than. That little equal to line does not affect anything, so I'm still going to do the one I just described. So the absolute value is by itself, so I'm going to say the stuff underneath, x plus 2, is less than or equal to 6. In other words, just leave it alone. Second equation, I'm going to say x plus 2, and we flip the inequality, so greater than or equal to, and then now we do the negative 6. So the only difference in this and what you did yesterday is that in one case you have the less than, in the other case you flip it and you have the greater than. So we still solve each one separately. If I subtract 2, I'm going to have x is less than or equal to 4. On this one, if I subtract 2, I'm going to have x is greater than or equal to negative 8. And so think about where these overlap. If you picture, not that you have to draw a number line, but if you picture the first one, x is less than 4. So let's say here's 4. So x is less than 4, so everything less than on this side. But if I take the second answer, the x is greater than or equal to negative 8. So if you were to put on negative 8, it would be over here somewhere, negative 8. And if I want everything greater than negative 8, then it would be everything in this direction. And so earlier I said the answer is the intersection. So where do those two overlap? Okay, my dog's going crazy. Sorry about that. So where do those two overlap? Well, they overlap between negative 8 and 4. So that means the solution is the intersection. So it's everything between negative 8 all the way up to 4. So that's not, whoops, I don't want that parenthesis. I want a bracket, right, because of the equal to. So because it's an equal to, I'm going to say bracket negative 8, bracket 4. So that means everything from negative 8 all the way up to 4. It's not an ordered pair, it's an interval. Okay, let's try another one. This is a less than. So we write our two equations, just like we talked about before. The stuff underneath, 2x plus 1 is less than 9. Second equation, stuff underneath, 2x plus 1, flip your inequality, so greater than negative 9. So there's my two equations. So let's solve each one. So subtract 1, that's going to be an 8, divide by 2, so x is less than 4. Second equation, subtract 1, it's going to be negative 10, divide by 2, so it'll be negative 5. Okay, so again, we need to think about where do these overlap? Well, the first one, if this is 4, I want everything less than 4. The second one, if I want x to be greater than negative 5, so negative 5 is over here somewhere, I want everything greater than. And so I want the intersection of the two. So the intersection is from -5 to 4. And since there wasn't an equal to on the original, I'm not going to use a bracket. So I'm just going to say parentheses, -5 to 4. Again, that's not an ordered pair. That's an interval from -5 to 4. Okay, notice number 3 and 4. The original equation is not a less than, right? See, the original equation is a greater than. All right, so how do I handle greater than? Well, that's my second situation. So I'm still going to write my two equations. I'm still going to keep one exactly like the original. In this case, you start with your original being greater than. And the second one, you're going to flip your inequality and make it negative. But this time, the answer is not the intersection. It's not where they overlap. But the answer is, textbooks will say union, basically meaning you want both answers. Doesn't matter if they overlap or not. In fact, they probably, in most cases, won't overlap. So when I look at number 3, so I'm going to write my two equations, right? The absolute value is already by itself. So first equation, stuff underneath, 4x plus 5. And then you just keep writing exactly what you see, greater than 13. Second equation, 4x plus 5. So it's the second equation that you flip the inequality. So this time is the less than, and you also make it negative. Okay? So we solve our two equations. So subtract 5. That's going to be 8. Divide by 4. That's 2. Okay, again, solve the second one. Subtract 5. It's going to be -18. Divide by 4. So I'm going to have -18 over 4, but I want to simplify that to be -9/2. So in this case, if I were to think about the number line, I might say, okay, here's 2. If I want x to be greater than 2, then that's everything over here. And think about this, x is less than -9/2. Well, negative is definitely over here. I mean, as it turns out, 9/2 is like 4.5, but I don't even really have to know that since it's a negative. I know it's over here. And if I want x to be less than that, it's this direction. Well, notice they don't even overlap, but it didn't matter. They didn't have to overlap. So really on these greater than problems, you don't even really have to think about the number line because I don't care if they overlap or not. So basically, I just have my two answers. The first one, x is greater than 2. Now, if you wanted to write that, so that's this one right here. If you wanted to write that as an interval, you could say, oh, from 2 to infinity, but you don't have to write it like that. I mean, you could, you don't have to. Or my second answer, remember right here where it said x was less than -9/2. So if you want, you can just say, okay, there it is, I'm done. Or if you want to think about the interval, you could say, wouldn't that be from -infinity all the way up to -9/2? So if you want to write it as an interval, this interval is the same as that solution. You can write it either way, doesn't matter. Okay, so let's look at the last one. I'm going to write my two equations. So x plus 4 greater than or equal to 6. X plus 4, so this is the one where we flip the inequality, whatever it was, we flip it, and I write -6. Solve each one separately, so subtract 4, x greater than or equal to 2, subtract 4, less than or equal to -10. Okay, so since I don't need to draw a number line, I don't think I will. I could just stop right there and say, okay, here's my solution. X is greater than 2. If you wanted to write that as an interval, let's say greater than 2. So that'd be from 2 on out to infinity. And of course, I'd use a bracket on the 2 because of the equal to. Or this second inequality, when x is less than or equal to -10. Well, if it's less than -10, that means it's from -infinity up to -10. Again, I would use a bracket on the -10 because of the equal to. So either way, I have the two solutions, right? Two intervals. All right, so that is absolute value inequalities.